everyone, welcome back to my channel EduVibe. In today's lesson, we'll start with another unit of the grade 11th math, which is the radicals. And this is the unit of third unit of the grade 11 math. And after that, we left with only 2 units and we completed the grade 11 math. So, so, in, so radicals are the thing when we use the roots, like this one. This roots type of any expression will tell that this is the radical. In this unit, we're talking about the radicals. We're talking about the absolute values and the reciprocal things, and the functions of things. We'll do some graphs of this too. But today, our main focus is to understanding the radicals, how to multiply them, how to divide them, how can we add or subtract. So these all things we do. So we do the working with the radicals. So this is time of the lesson when we do more calculation based, and we have to know that how can we calculate the radicals in their simplest form, in their mixed form, like all the things. So let's start with some introduction part of the radicals, that what are the radicals. So here they tell that determine the value of each of the following. So these are the simple ones. So first one is that cube root of 8. So 8 is a cube root of, and 8 is the cube root of what? So when you multiply the 2 3 times, this means the multiply of 2 3, and these all are basic understanding of the grade 10 math. So this is equal to the 2. So 2 into 2 into 2 will give you the 8. Then we have a fourth root of 81. So when you multiply the 3 4 times, you will get the 81. So this means this is a 3. So when you divide the 3 into 3 into 3 into 3, so this will get you the 81, which is the 3 now. So that's how the radical work. This is all the grade 10 math. The summary of this is the symbol. The symbol we call it this. The root as some number in that or something over there, and which is 3. For 2 we can't write 2, so this means that root. For 3 4 5, any n number is called an nth of root of x. For the TI-84 math, when you TI-84, when you have the root of anything, so you do the math 5 and this button, this type of, when you do formula TI-84. So this is you steps have to follow to put that root sign for this. But you actually know that how can we solve this. You not depend on the scientific calculator. You have to do how can we solve it actually, and we do those things in that unit too. So these are the parts. This 25, which is called x, is the radicand. We call it a radicand. That 3 is called the index, that outside value of any cube, square, or anything. And that whole thing will call as the radical. So that whole form is called a radical. So that's you have to know, and we're working with the radicals now. So let's do some examples, and before certain examples, we have to know about some restrictions. So in the radicals, we are not doing these things now anymore, like these simple things. We're including the variables in this now. And when the variables are any alphabet is going to do in this, any variables are coming, so we are come to know about some restrictions concept. So there's all the restriction on variables in a radical. So if there's any radical and we have a variable in that too, so we have some restrictions of this, and we have to mention that restriction to that to know that when whatever the value we get, that restriction can be considered at that way, that this value is the restriction, so this value is not the answer for that. We do that things in upcoming lesson. So the first one is that the root is square of 5 minus x. So this is whole the square, this square is like this, the whole thing. So this means that square of 5 minus x, this is in the value is in the radical. So this is the thing where the restriction can be taken. So what we do, that if you have 5 minus x, so you do 5 minus x greater than equal to 0. You start with greater than equal to, which is 0. Then when you have to divide or multiply with minus from the left hand side or right hand side, then we flip the sign. So this is 5 minus x greater than equal to 0. When you move that, you will get x. So we will get x greater than equal to 5, less than equal to 5. So you get this thing, which is the solution for this. And when you get the answer, if the anything is greater than that thing, greater than 5, So that value is not be our answer. That we rejected that value. We always consider the values which are between the which are like x, which is less than or equal to the 5, not greater than. And for next one we have a 4 root of x plus 8. So this is again the full thing, like over there root is all thing. So x plus 8 is greater than or equal to 0. So s is greater than or equal to minus 8. So it's a simple thing. Next one too, x square plus 9. x square plus 9 greater than or equal to 0. That thing has no restriction. Why this had no restriction? So always true if the this restriction always true if the x belongs to all the real numbers. So there is a no restrictions on the things where we get the square. So if in the radical, if in any root, you get the square of anything, of the square of any variable, so that means that radical has no restrictions. So that's the another thing you have to know in this. In the next question, we have a 7 plus x of the square, root square of 7 plus x, which means 7 plus x greater than or equal to 0, which we get this x is greater than or equal to minus 7 of this. Next we have a fourth root of minus x plus 4, which minus x plus 4 greater than or equal to 0. So this is 4 greater than or equal to x. So we have x, and that will reverse the sign because we divide with minus 1. So this is x is less than 4. Again, we have a 2x minus 9 of square. So 2x minus 9 greater or equal to 0. 2x greater or equal to 0. So do we get 9 by 2? Or you can solve this, you get like 4.5x. So that's all the restrictions can work. If there are any square of variables, so no restrictions. Otherwise, you have restrictions for everything. Done? So that's all you have to do in the restriction variable, and we have to take care of this when we're doing the equations mainly. When we do the equations, so then we take care of this. So now we are doing some actual calculation in the radicals. In these questions, we will not consider about any the restriction thing because we're not doing the restrictions in this for now, but we do that when we do the any equations in the radicals. So let's start with this. So S plus East missed radical in the entire radical form. So in the entire radical form means we have to be in that form, this form. So this is like missed one, like you have a outside, and sometimes you have like sits a like this. So you have to be in like actual radical form, which is very simplest radical form. So how can we do that? So we think about this now. Okay, we have a 7 root 2. So how this 7 comes out of the root? So you know that when anything is the double in the like this is a square thing. So this means you have to think about it twice, like 2 times. Like if we have a wait, like if you have a 2 into 2 into 3, if you have this thing, and you have to be like in square of this. So if there's a square means 2, so if these two things are like repeating the 2 times, like 2 is repeating 2, and we have a square of this, so this 2 comes out, and this 2 will come it as 1 2, and we left with 3 only because 3 has not paired with anything because this is square for this. And for this one, this is the 7 square of root, which means 7 is a square inside of this. If 7 is a square inside of this, which means the 7 square multiplied by 2 like this. If this is that form, this will get to the 7 root 2. But we want the entire radical form, so we have to solve this now and be in like particular form. So 7 square is 7 49. So you get 49 multiplied by 2 square of this, and you will get square root of 98. This is the entire radical form we want. So that's how you have to solve these questions. We have to take care of which root we have. We have a square, we have a cube, we have fourth root, we have fifth root. That thing you have to keep in your mind that which thing you have. Like in this example, we have a square, in this too we have square. Next one, we have a raised to power 4, which is a square of a. Which means that a4, when it's inside the bracket, is a square of this. Okay, so when this is in the inside, so this is a4 and the whole square of this multiplied by a. And when you solve this, you get like a8 multiplied by a, which is like this, and this is the multiplying, and bases are same, so we do plus the root. So 8 plus 1 is 9. So you get a root square root of a raised to power 9. And now we in the radical we have a one variable in this. So this is an easy thing we have to do, like a is not equal to 0. A greater than or equal to 0. We take that thing. If we have like any answer, we get this like this, we have to be put some restriction on that in the variables only. So like that instruction we have. In the next one we have a 5b, and then we have a cube root of 3b squared. We have a 3b squared as whole. Now that 3b inside the bracket is a cube now. Why the cube? Because we have a cube root now. Here we have a square root, so we take as square, like square of that outside thing in the inside. But there we have a cube, so inside this is a 5b whole cube. Like we have a 5b, this is the whole cube multiplied by 3b square of this. When you solve this, this is a cube in this. So when you solve this, you have cube. So 5 into 5 multiplied by 5 into 5 multiplied by 5. So 5 multiplied by 5 is 25. 25 by multiplied by 5 is 125. So 125 b cube into 3b square. Now this is multiplying. So 125 multiplied by 3 is 375. And 3 plus 2 is 5. And this is like cube in this. So this is the answer. This is the radical form. That's how you have to solve, and that restriction is also like b is greater than or equal to 0. If there's a single variable in the radical, so it's easy to see the thing. Next is again simple thing. 3 square root of 7. So this square multiplied with 7, you will get 9 into 7, which is 63. In next one, this is again square. So now you do with your own. So this is square with this. So 6 times 6 is 36. A4 multiplied by 3a, and we get root. So 36 times 3 is 108. A5. You get this, and a is again equal to 0. So that's how you can do the mixed radical into the radical form. And if we have a reverse of this, now the entire radical form to the mixed radical in the simplest form. So it's the backwards you have to do. So how can we do this? So you have to break down the thing which is inside the radical. Like here we have a root of 108, and we have a 108 inside this. So you have to break down this like that, when the repeating things, when the pair of like this one to square, the repeating can be go outside the bracket. Have to do like this. So in that case, you have to get the LCMs. So LCMs you can also take in grade 10 math, I think. So the LCMs can be easy thing, that I will show you one, and that all thing I will do with my own. So for the LCM, you have to do like this, and we have 108 over there, and we are divisible, like we have to find the factors of this, where the multiples of this. So 10 is like very much divisible by the 2. So when with 2, so we have 54, again with 2. So we have a 27, 3, now this goes on 3, not 2. So 3 times 9, 3, 3, 3, 1. You get this type of thing. Here your 2 is the square, so you take it as a 1 2. This 3 3 as a 1 3, and the 3 is left with that. So 3 that the left 3 goes inside the radical, and the rest of 2 multiplied by 3, you will get a 6. So this will come this line, that 6 root 3. That's the LCM can be taken by that. If not, if you want to like do something else, you can use that your method. But the LCM method is much easier, but sometimes it's not easier when you have like a variables like that. So for the variables, I will do the another thing. I will tell you that. So for the simple ones, I will do like this. You can also do like this if you want. For the next one, there are threes remain inside, like 3's remains outside. But 48 can be like divisible by this. So 48. So 48, so you have to consider some numbers in your mind, some tables in your mind. So if we write as a 48 is like 16 times 3. 16 times 3 is 48. And 16 can be written as 4 into 4 into 3. So it's the easy thing that 4 can be go outside now. So you have like 16 into 3 you do. The 16 can be square of 4. So 3 into 4 root 3. You will get 12 root 3. Easy. Next thing we have a like cube now. So 6 cube root of 54. Now you have to say the any cube root number. Like in the square number, we can say the numbers like 2 times 2 is 4, 3 square is 9, 16, 25, 36, 49. That squares we consider. But for the cube, we have to consider some cube values. Like for this, we have a 2 for 2 cube is 8, 27, we have 64, 125, 216, 343. Like these cubes we consider now. So for like cubes, we have to say some tables now again. That 54 can be divisible by 2 and is divisible by 27. So you can write it like this. So this sets, you can write it 27 multiplied by 2. Now that 27 is the like 3 times when you do 3 cube. So this goes to outside the bracket. Left with 2. So 6 times 3 is 18. And this is the answer for it. So that's when we just consider the values and the like this thing you have to some like critical thinking of your mind. You have to memorize that something like these things, that these roots you have to memorize. So that if you know this, so this is easy for you. Let's do the next one, which is minus 6 square of 32. Now the minus, so nothing like different in this. You take it as minus, and then 32. So you can take it as the 16 times 2. 16 times 2 is 32. 16 goes outside, which is multiplied by 4. And you will get minus 24 root 2. For next one, minus 3. 4th root of 32 C99. Now you get a something else. This is not 99. This is only 9. So you have to do C raised to 9 only. So this is like different thing now. So if for this type of thing you have to like, if you like doing like something like in your mind, you say this is a difficult for you. So take it individually. Like minus 3 is a like constant over there. So 32, it means like that, which is 4. And you can multiply this, the variable thing like separately. It gets separate. Now for this, for 32, if you're doing like, this is a 4th root. So this is 4th root. So if you like doing the anything with the 16 times 2 if you do. But you see that this is 4 now. So why it is 16? 16 I take because if you do the 2/4, you will get a 16. You will get a 16. That's why I take 16 times 2. Which will give me 32. And I take it as a 4. Or no, 2. Because we have a 2. If you do 4ths, then they do. So I take 2 in bed with outside. And I left with only 2. Now for variable. Now we want for 4. So we have a 6, 9. So what you actually doing in that you do like if you have a 9, so 9 is not on 4th table. Like if you know the table of 4, so you can see that 9 is not on 4, but 8 is on that 4th. So 4 times 2 is 8. So 4 times 2 if is 8, so this means that 8 can be like get the all 8 from here and put the c square on that. You'll have to do only one c inside the bracket. If that c square wants to go inside, so it goes like c square, it goes like c square whole square multiplied by c, like this. Therefore, it is the 4th root. So when you solve this, you get about 6, 8 multiplied by 6, 4, and you get this 6, 9 again. That's the reverse thing you do. So same like with this. So when you do like this, you get the answer. So this is actually the c square 4, and this is the c over there. Now you have to like combine all things. So minus 3 multiplied by 2 is minus 6. And you have over there c square. And that 2 multiplied by 6. This is inside the root, so they multiply with each other. You get the 2c. This whole is your answer. You can solve it like that. And to consider that, so you have to do some thinking now in this. In the next one, we have a 48y raised to a 5. So it's a scale now, it's easy. So separate things if you want. So 48. So 40 is again, I take that 16 times 3. So 16 times 3 is 16 times 3 is 48. And multiply this by the y5. So now 16, like this is like I take as 4. So if 4 is multiplied by 2 times, you get 16. So 4 root 3 multiply. Now it's a square and you have a 5, which means that 5 is not on 2's table. So you get a 4. 4 is on the table. So it has, and 4 is on like 2 times 2 is 4. So it's y square and you're left with only 1y, which is that. So you can solve this. So 4y square and you have a 3y. For this, you have to take the distinction y is greater than equal to 0 for this too. C is greater than equal to 0. So that's how you can solve these answers, and this is like something critical thinking you have to do, and you have, when you do some practice of this repeatedly, then you like very good in this, I think. Have to do some critical thinking in that. Now we have another thing. Now we do the adding and subtracting. So convert to the like terms, and then the add and subtract to simplify. Now you know the how then we convert this to mixed radical, how to make entire radical. Now you use that thing and do the plus minus, and then you have to do some multiply divide with that. So we have a square root of 50 plus 3 root 2. Now firstly you have to be in the same like terms. Like your roots, like if this is root 2, this should be like root 2, like smallest thing. Like you can't like make root 2 be the root 50. You will make the fifth root 50 to 2 if you want. So you have to be in the like terms, like all the two things like root 2 can be like multiplied with each other. Not the, like this is not like plus by each other. You have to be in the same terms. Like if the root 50 can be in the entire radical, if you want to find into entire radical, so you can like do it by the, you can say this thing, so 25 times 2 will give you 50. So plus 3 root 2. So 25 is the square of 5, so it's 5 root 2 plus 3 root 2. Now you have a same radicals over side. So you can now plus them all. So if this is same, so then you want plus. So 5 plus 3 is 8. And this remains root 2. This is not multiplying. If there is a multiplying, so the roots inside the roots can be multiplied with each other. But in that case, the root 2 remains root 2 because we do the plus and the minus 2. That thing you have to know in this now. Next one. We have a minus 27, 3 root 5, minus 80, root 80, and a minus 2 root 12. You can solve this easily. So that 27 is same like if you understand the root. So 3 times 3 times 3. So that 2 3's goes outside. So minus 3 and we have to 1 3. For this is not like anything you have to solve. This is simply in the entire. So you can tap it like that. For 80, what you do? If it says that 16 times 15, 5, 16 times 5 will give you the 80. So the 16 comes off with the 4, the root 5. Minus. You have a like 2 root 12. So 12 times 8 is a 2 into 2 into 3. So 2 is going outside, which is 2. And there is a constant we have over there. We have an instant over there, which is 2 again. So 2 times 2 is now 4. So outside the bracket you have to consider now. So 4 root 2. You have minus, no, it's 3. So it's 4 root 3. You have minus root 3 minus 4 root 3 plus 3 root 5 minus 4 root 5. This will give you the minus 3 minus 4 will give you minus 7 root 3, and this plus 3 minus 4 will give you minus root 5. So minus 4 is bigger. So that's your answer for this. You let's stop it there. Next thing, we have a root 20n minus with minus 3 root 45n. That n should be remain inside because this is 1 and this not like come outside in the bracket, and n is equal to 0. So for this, so 20, we have a 20. So 20 can be do like 4 into 5, or you can do the 2 into 2 into 5, which will give you the 20. So 2 is goes outside and you're left with 5n. Same with this. So 45 now. So 45 is like a, you do 3 into 3 into 5. 3 into 5. So you get 3 and 3 is outside there already. So you do 3 times 3 is 9. And you're left with the 5n. So 5 and 5n is now like terms. So you can solve this with minus 7 root 5n. Again, you can put the restriction if you want as the answer. So that's the adding and subtracting with the like terms. You can add and subtract all when you have a like terms, not with unlike terms. Let's do multiply and divide. So multiply and divide is much easier because you have to just do the multiplying things. And this thing have to be focused in that. So first one is that 2 root 3 and we have in bracket 3 root 6 minus 4 root 15. This is nothing you have to consider anything like we do like you have to say like this should be in like like terms. It might be not. You have to just solve this. How can you solve it? This is like a distribution thing. So this thing multiplied with this, then this multiplied by this. So 2 times 3 is 6. In the root, we have a 3 times 6 is 18. Then we have minus. So 2 times 4 is 8. 15 times 3 is 45. Now if you want, so you can simplify the more than this. So 18, we have 18 can be simplified anymore. Yeah, you can simplify this. And if you simplify this, you get the like 18 outside. Because this is 3 outside, so 6 times 3, you get 2, root 2 minus, and 45 is like gain. You have like 3 into 5. So 3 goes out, 8, 3 is 24, and you're left with 3. Now you can't solve, so it's 5. So now you can't solve anymore in up to this. So now you consider that whole thing is like all are collective with each other when you do that thing. Now the missed entire radical, that plus minus, that all can be like go with each other. Next we have a 2 root 3 of 11 k square, and we have a 4 cube root of 2 and plus 3 cube root of 3 k, and n is greater or equal to 0. K is greater or equal to 0. So for this is with 11. So you can say it like that. You can multiply this. So 2 times 4 is 8 cube root. 11 times 2 is 22. And we have a k square. Plus 2 times 3 is 6. That 11 times 3 is 33. And we have a 2 k square and k, which will give you k3. If you can solve, then you can solve many more. Like this can be solved. This stays the same. This one is also k3, and we have a cube 3. So k can, all the 3 k's are those outside with the k, and we're left with only this thing. And you get this. So these are the multiplication. And multiplication divide are much easier. So I have only 2 examples for that. Let's do the division for now. So we have a 12 root 24 upon 2 root 3. This can be the easy thing now. How can you solve this? Solve this by like 12 and 2 can be cut with each other. This, then we go. So wait. So this will go with this. So 6 we get. You get 6 root 4 upon root 3. If you want, so that root, if you have a root 24 upon root 3, that can be solved like this. So if that this can be cut, so you can cut this with that. You will get more precise answer. So this root goes out, you get root 1, and which is 1, so that's 1. And this is root 8, this can be again solved with that. So 6 root 2 like this. You get 6 2, which is 12 root 2. I solved this because we want like something example which is like very simplest one. For this is the whole root like this. So 3 divided by 2 is can't be solved. Stays like that. So this can be do something. So 27 with on 9, and this is on 16. We cut it on. When you cut it, like you get like root 16 and root 9. This can further be solved. So root 16 is 4. Root 9 is 3. So 3 times 4 is 12. 2 and 3 is 6. You can further resolve this. Get the 2. You get like a more simplest answer in division. You have to be in the like more simplest answer, like these two. This can be do. let's conclude this now. So that's the adding, subtracting, radicals with multiplying, dividing, and this is very important lesson for you because this will do some radical thing. Now we use that things in the equations, in the graphs and questions. So that's all for this lesson. Next lesson we do some rationalizing with denominators with the radicals. So learn ways of EduVibe, learn smarter, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till let's get it with EduVibe.